Hi, this is MD0 from Majumder, ID 219551886, the video for assignment 3. So here we go. Here's the spreadsheet that I made for it. What's special is you can see the greens. Not special, just how it is. So the greens are inputs. Like manually, you just got to put these in. Like they're givens and stuff. Well, everything here is like formula. So there's no inputs here. These are just, you can see every single one of these. Yeah. Also, this spreadsheet was made from the group project, since I already did this calculation for the group when I was calculating the benders for the shaft when we were designing the gearbox, so I had to was able to reuse it. So here we go, let's start. So for the pinion, here's the formula for the pinion, so it will be 12 plus 2 times y over here. The diametral pitch, these are given, the gear teeth given, the pitch diameters and all that. Got the RPM, which is over here from this equation, and then you have the transmitted loads and power, which is also given. Torque, which I don't have, but we did calculate the speed, the transmitted torque, and the transmitted power. So this is interesting that this is the same as this, which means that it's accurate. And the pitch angle, which is 20 degrees over here. So we got the modules over here, so 2.5, which is from the gear teeth, and 1. So this is also another input's a spur gear, so spur gears is 1 for spur gears. Alright, starting off with the pinion wear, we got the geometry factor I. You get that from equation 1423, which is over here. That's I. Got all these. Got QV, so this is the standard from the HDMI standard, so it's going to be 3 plus H7, so my one is going to be 11, so very high precision standard. I get the dynamic factor from 1427, equation for it is here. So you get A and B, and you can get your QV, your sulfur, KV, dynamic factor. So the face width is 3, this is given. This is the face width calculation, but we're actually using the given face width, which was given 3 inches. So now we can calculate for our load distribution factor, Km. So Km has a bunch of like coefficients or something. So you got this value, 1432, 1431, 1433, 1434, 1435. So a bunch of equations for these, which they're here, like 1432, yeah, 1430, 1434, and 1435. Yeah, I got them all there. So we get our Km, so the load distribution factor. So it's going to be steel, so CP is going to be 2300. So the overload factor is going to be 1. I guess assuming there's nothing there. So size factor is going to be 1.1 from this equation here. So we got this equation from the Y, or whatever the value that is. So this is that. And yeah, it's not okay. So the surface condition. So if it's commercial, so it'll be 1. And then you got, finally you can get from equation 1416, we can get our contact stress. So here's the contact stress equation. Use this equation right here, got all these factors, these variables that I needed to calculate that, and here is 83,000 psi. The life type is going to be 100 million as given, and you get Zn. So Zn, I got Zn from this graph, figure 1415, so it's 100 million cycles. So it'll be this equation, 2.466 n to the power of there. So yeah, that is the equation that I'm using. So reliability, so it's 99.9% reliability, so it's 1.25. There's a table for that. And the temperature, there's nothing about that, so it's just 1. And finally for the pinion, the CH value, which is 1. For pinion, it's 1. And this is the pinion gear. Finally, we can get our the gear. So there is a from table 14.5, but it's actually from table 14, from figure 14.2. So let's see if I can find that. Here's a reliability table as well. So yeah, 1.25. It's here somewhere. Okay, well this is for ST, but it's the same principle for ST and SC. So this is not the right one. So it'll be So yeah, it's right here. There's be an equation given for grade 1, which I used. So it's not this one, but yeah, this is the equation for a contact. And after this, we can finally use equation 1418, which is down here, or yeah, right here. Equation 1418, which is right here, to calculate for the safety. So safety factor is actually SH, so this is safety factor, and I rearranged it with all these values that we have. So we have the contact stress, we have all these, and we can get the factor of safety, 0.95. Same thing for the pinion. So after that, so we can move on to the pinion, the bending factor of safety, that's the wear factor, so the bending factor, so J. So we got a J. J is from a graph right here, this table right here, this figure 14.6. So for the number of teeth, it's like what is it, 16 or something. So 24 is going to be right here, so it's 25, 0.25 right here, and that's what that is. Then you got KB, which is the rim thickness factor. For it's constant thickness, so it'll be 1. Then I got my theta. So this is from equation 1415, which is going to be right here. Yeah, equation 1415. So I calculated it here, and yeah, got all the factors. Was able to load factor, and got the bending stress. I got Yn. So Yn is similar to Zn, but it's for bending. So here is the graph. If I can find the graph for Yn, yeah, here's the graph for Yn. So 10 to the power of it again. It'll be using this equation, and 1.358, which is 1.6831. Yeah, and I can get from flame hardened steel again using. So now it's actually going to be using this one, so 77.3 HB plus 12,800. So this is for the pinion. It's going to be this one. There it goes, and I can get the bending factor of safety. So for the that's after the gears. Sorry, for the pinion, for the gear, it's going to be basically the same thing. A few things are different. CPF is different because the pitch to hammer is different, and other than that, it's mostly similar. Okay, it'll be different. Yeah, this bending stress will be different because of that, and Xenia and all this will be pretty similar. Oh, this will be different. So we'll actually use the formula, using this formula right here, to calculate the CH. It's not just going to be 1 because it's greater than 1, so here. This one was less than 1, so it was just defaulted to 1 when I could use the calculation, so this will be 1.18. Yeah, same thing basically, use this calculation instead of this one, used the top one, the Bernal hardness, but this one uses the bottom Bernal hardness is given. Yeah, and we can calculate the wear factor of safety for the gear, and the same thing here, different J, do the different number of teeth, and other than that, pretty similar, and we can get our factors of safety, 4 factors of safety right here. So, last thing, what is the critical piece? It's going to be here for the pinions. The wear factor of safety for the pinion is too low, it's 0.95. So that's the highly critical at risk part, that is at risk of breaking apart. Yeah, the rest of the parts, their factors of safety are not that bad. I think in the book it's like 1.2 was the ideal, so 0. So this is above 1.2. This one though, 0.95. It's the contact stress is too high. It might have a failure. There might be failure here, a chance. Alright, so there you go. Thank you very much.